The idea here is very simple. From sum is equal to average into number of terms, we go to change in sum, delta S is equal to change in average into number of terms. And the reason why we do it is that we can do calculations on smaller numbers, and those calculations would be faster. Save time for mental calculation, that's all. If you're just brute forcing on a calculator, this doesn't really make a difference. Okay, let's see how this is used. Let's look at a simple question. Let's read the question. PQRST are 5 people. They have an average weight of 74.2 kg. P, who weighs 71 kg, is replaced by U, who weighs 80 kgs. Find the new average. Now, this is a easier question. This is a easier kind of question where you can apply this method, because replacement, which means one observation is leaving and another is taking that observation's place. So the number of observations is constant, n is constant, and it's easier to apply this technique when n is constant. So let's look at that first. The idea is pretty simple. The change in sum is change in average into number of terms remaining constant at 5. What is happening to the sum? When a person weighing 71 kg leaves and a person with 80 joins, the sum is going to rise by 9, right? And so plus 9 is equal to delta A into 5 will give you delta A is equal to 9 by 5 is equal to 1.8. So the average rises by 1.8 kgs, which means that the new average is 74.2 plus 1.8 is equal to 76 kg. Now what you'll notice is that it's way easier than doing 74.2 into 5 minus 71 plus 80 the whole divided by 5. That's essentially what you would have done in the absence of this technique. Let's find the old sum. Who left, who came in his place. Let's find the new average. And what this method does is simply that it distributes it. This part is 74.2 itself, while this part is 9 by 5. That is all we have done here, and gives you 76 kgs. Let's look at this question again. The average of 47 numbers is 57. It rises by 1 when a 48th number is added. Find the 48th number. So the problem here is n is not constant. So it's a little tougher to apply our delta S approach here, but it can still be done. And I want to elaborate using the diagram as well. So if you have 47 numbers with an average of 57, that can be represented by a 47 by 57 rectangle. N is equal to 47, A is equal to 57. And the area of this rectangle is the old sum. Now, if the 40th number is also equal to 57, the average wouldn't rise or fall, the average would hold. So the 40th observation needs to bring in a 57 just to maintain the average, and it needs to bring in more than 57 to raise the average, and the excess beyond 57 is the part that causes the rise in average. So this is basically what it looks like. It brings in a 57 to hold the average, and it brings in something extra to raise the average, and that is the delta S here. So this delta S is equal to delta A into N. And what is the average change in average? The average rises by 1, so that's a plus 1. And the N used to be 47 people, now it is 48. 48 observations are there. You always use the final value of N, because this extra is redistributed like this to raise the average. The extra also goes to the 40th observation as well. So that means you have to use the final value of N, and so delta S is 1 into 48 is 48, but that is not the 40th observation. It is the quantity by which the 40th observation exceeds the old average. That is the way you want to look at it. The height of the last block above the old average, that is 48. So that basically means my 40th observation is 48 more than 57, which gives me 105, which is the same answer we got last time. So this is how you apply the idea behind applying the delta S equal to delta A into n principle. When n is changing, use the final value of n, and whatever you're getting is not the answer, it is the amount by which the new observation exceeds the old average. We'll look at a couple more examples.